That tiny point of light glowing beneath Saturn's rings in this image is not a distant star. It is us. It is Earth, every ocean and mountain and living thing, shrunk to a single pixel and photographed from nearly 1.5 billion kilometers away. The spacecraft that turned its camera back toward home to take this portrait was called Cassini, and by the time it captured this view, it had already spent 2 decades wandering the outer solar system. Across its lifetime, Cassini traveled close to 8 billion kilometers and looped around Saturn nearly 300 times. It slipped between the planet and its rings, skimmed the surfaces of frozen moons, and chased storms larger than our entire world. The Cassini-Huygens mission was a string of bold gambles stacked one on top of another, and somehow nearly all of them paid off. Giant worlds like Jupiter and Saturn are time capsules. Locked inside them are clues about how our solar system came together more than 4 billion years ago, and reaching out to study them is less like engineering and more like choreography. Only 4 robotic visitors have ever made it to Saturn, and of those, only one stayed long enough to circle it again and again. The other 3 simply waved as they raced past. That one resident was Cassini. So buckle in, because I want to walk you through the entire adventure, from the launch pad to the final plunge. On the 15th of October in 1997, the night sky over Florida lit up as a Titan 4B Centaur rocket roared off the ground, hauling Cassini toward the stars on a column of fire. But Cassini did not travel alone. Strapped alongside it rode a probe built by the European Space Agency named Huygens, a little machine destined to become the first object ever placed by human hands onto a surface in the far reaches of the outer solar system. This was no modest piece of hardware. Cassini-Huygens ranked among the heaviest interplanetary vehicles ever assembled, tipping the scales at roughly 5,000 kilograms fully fueled. That bulk created a problem. No rocket of the era could simply throw something so massive straight to Saturn. The spacecraft would have to borrow speed from the planets themselves, swinging past them and stealing a little of their motion with each pass. And so, the path to the ringed planet was not a straight line at all, but a winding detour through the inner solar system. Roughly half a year after leaving Earth, on the 25th of April in 1998, Cassini swept past Venus for the first time, then circled back for a second pass the following year. Each encounter handed the spacecraft a generous push, building up the energy it needed to climb out towards the asteroid belt. But gravity is a stubborn thing. After the Venus encounters, the sun's pull tugged the probe back inward, and that detour created an unexpected opportunity, a chance to visit the place it had come from. Almost 2 years into the voyage, Cassini swung past Earth for a gravity boost of its own. This was a tense moment for the mission team, because the spacecraft carried radioactive material to power its instruments, and any miscalculation near home would have been unthinkable. As it sailed by, Cassini practiced on a familiar target, snapping pictures of Earth and the Moon to fine-tune its cameras. Those were the very first images the mission ever produced. The flyby accelerated the craft by more than 5 kilometers every second, just enough to break free of the sun's grip and aim itself outward for good. With that, Cassini joined a short list of spacecraft to push through the asteroid belt and keep going. Then, at the very end of the year 2000, Cassini reached Jupiter. For 6 months, it studied the largest planet in the solar system, gathering tens of thousands of photographs of the gas giant, its delicate rings, and its swarm of moons. The mission stitched together some of the finest full-color views of Jupiter ever made at that time. One frame in particular became unforgettable: the volcanic moon Io hanging in the foreground, with the banded face of Jupiter looming enormous behind it. After the Jupiter chapter closed, Cassini pointed itself at last towards Saturn, but the cruise was never wasted time. The team treated those quiet stretches as a laboratory, running experiments that had nothing to do with the destination and everything to do with the laws of the universe. The most remarkable of these unfolded in 2003. Scientists fired radio signals from Earth out to the distant spacecraft and listened for them to bounce back. As those signals grazed past the sun, its immense mass bent space itself, nudging the radio waves ever so slightly off course and stretching the time the signals took to make the round trip. By measuring that delay with extraordinary precision, the mission put Albert Einstein's general theory of relativity to one of its sharpest tests yet. The numbers held. Cassini's data backed Einstein beautifully, tightening the accuracy of the theory to roughly 1 part in 50,000. A spacecraft built to study a planet had paused, mid-journey, to confirm how gravity shapes the cosmos. It is worth pausing on how strange that is. Einstein never saw a rocket leave the ground, yet a machine drifting hundreds of millions of kilometers away, decades after his death, became one of the most precise courtrooms his ideas were ever tried in. The empty space between Earth and Cassini turned into an instrument, and the sun became the lens. Every kilometer of distance that made the mission harder also made the experiment sharper, because the farther the signal traveled, the more clearly the bending of space revealed itself. By February of 2004, after almost 7 years in flight, Cassini was closing in. What followed was a flood of discovery, unlike anything the mission had produced before. Over the years that followed, the Cassini-Huygens team would identify 7 previously unknown moons circling Saturn, hidden until a sharp-eyed visitor finally arrived to find them. In the middle of 2004, Cassini drifted past a small, dark moon named Phoebe. Its photographs showed a battered, crater-pocked surface, with patches gleaming brightly against the gloom. Those bright streaks hinted that a great deal of water ice lay buried just beneath the moon's outer crust, a frozen reservoir locked away in the cold. Then came the moment everything had been building toward. On the first day of July in 2004, Cassini fired its engine and let Saturn's gravity capture it, sliding into orbit around the planet. With that single maneuver, it became the first spacecraft in history to circle Saturn rather than merely glance at it from a distance. A day later, it made its first close pass of Titan, Saturn's largest moon, gathering early glimpses of strange dark features that looked unsettlingly like bodies of liquid. The real investigation of Titan, though, was about to begin in earnest. On Christmas Day of 2004, Cassini did something it had been carrying its companion across the solar system to do. It released the Huygens probe and sent it drifting toward Titan, alone. For 3 weeks, Huygens coasted silently. Then, on the 14th of January in 2005, it pierced Titan's thick orange atmosphere and began a long, slow descent, drifting downward for roughly 2.5 hours beneath a parachute before settling onto solid ground. No machine had ever landed so far from home. What Huygens revealed rewrote the textbooks. Titan turned out to possess entire seas, not of water, but of liquid methane, sprawling across its frigid surface. It was the first time anyone had confirmed standing liquid existing anywhere beyond Earth, and the discovery vaulted Titan onto the short list of places in our solar system where life might, just might, find a foothold. Where all that methane comes from remains an open question to this day, and some scientists wonder whether those chilled seas could shelter chemistry we have never seen before. Huygens was only built to survive a brief window, designed to relay information during its fall, and perhaps for a short stretch after touchdown. Instead, the plucky probe kept transmitting for around 90 minutes from the surface itself, before falling silent for good. Its work was done, but Cassini's was far from over. With Huygens gone, Cassini turned its attention to a far smaller world, one of the brightest and iciest objects in the entire solar system, Enceladus. Something strange was happening there. Cassini detected a curious bend in the magnetic field surrounding the little moon, a signature that hinted at hidden activity. When the spacecraft looked closer, it found the cause. Towering plumes of icy vapor were jetting out of cracks near the moon's south pole, spraying frozen material into space. Pass after pass, Cassini flew through and studied those geysers, and the evidence pointed to something astonishing. Beneath the frozen shell of Enceladus lay a salty ocean of liquid water, sloshing against a rocky seafloor. An ocean on a moon barely 500 kilometers across, far from the warmth of the sun. Think about what that means. For most of human history, we assumed liquid water needed sunlight and a place near a star to survive. Enceladus shattered that assumption. Here was a tiny frozen ball, drifting in the deep cold beyond the asteroid belt, somehow keeping an entire sea liquid beneath its crust, warmed by the gentle squeezing of Saturn's gravity. And those geysers were not just spraying ice. Buried in the plumes Cassini flew through were the chemical building blocks that life as we understand it tends to rely on. Without ever landing, the spacecraft had tasted the breath of a hidden ocean and found it strangely familiar. The discoveries did not stop there. Cassini sniffed out oxygen around the moon Dione and detected organic compounds on the battered surface of Hyperion. It even cracked a riddle that had puzzled astronomers for 3 centuries, showing that the strange dark markings on the moon Iapetus were the result of sunlight slowly heating one face of the world while leaving the other bright and frozen. One by one, the mission was solving mysteries that had stood unanswered since the invention of the telescope. For all the wonders of its moons, Saturn itself never stopped surprising the spacecraft circling it. Cassini studied the planet's famous rings up close and discovered they were anything but the smooth, simple bands they appear to be from afar. Instead, they rippled with waves, sculpted by the gravitational tugging of Saturn and its moons. The rings turned out to be made almost entirely of countless particles of water ice, and tucked among them were tiny embedded moonlets, miniature worlds shepherding the debris around them. By watching how the rings behaved, scientists gained a living model of the very processes that build planets from disks of scattered material. And then there were the storms. Saturn brews some of the most violent weather anywhere in the solar system, and Cassini was perfectly placed to witness it. In late 2012, the spacecraft observed the churning aftermath of an enormous tempest, a planet-spanning superstorm of the kind that erupts on Saturn only about once every 3 decades. The storm flooded the upper atmosphere with chemicals far beyond what anyone expected, and it was the first time such an event had ever been studied by a spacecraft orbiting the planet from above. A year later, Cassini captured stunning, high-resolution footage of one of Saturn's strangest features, a bizarre 6-sided jet stream swirling at the North Pole, a hexagon of wind that has no clear parallel anywhere else we know. The spacecraft also tracked the rhythm of the seasons across the giant world, recording how one pole gradually warmed while the other cooled as Saturn slowly tilted through its decades-long year. Cassini was only ever supposed to last 7 years. Instead, it kept going, earning extension after extension as it proved how much more it had left to give. The team granted it additional years of operation more than once, unwilling to lose a machine that kept rewriting what we knew. But every spacecraft runs on borrowed time, and eventually the fuel began to run dry. By 2017, the engineers knew the end was near, and they chose to send Cassini out in a way that matched the daring of its entire life. They called it the Grand Finale, a series of 22 breathtaking dives threaded through the narrow gap between Saturn and its innermost rings, a region no spacecraft had ever explored, gathering data no one had ever held. Then, on the 15th of September in 2017, Cassini made its final maneuver. It turned towards Saturn and dropped into the planet's atmosphere, transmitting all the way down until the friction tore it apart, and it became, in its last moments, a part of the very world it had studied for so long. The signal lingered for a few seconds longer than anyone predicted, as if the spacecraft were reluctant to say goodbye before going dark forever. There was a reason for this fiery ending. Enceladus and Titan might harbor environments where life could exist, and the team refused to risk a dead, drifting spacecraft someday crashing into one of them and contaminating it with microbes from Earth. So they chose destruction over recklessness, sending Cassini to burn rather than risk the worlds it had revealed to us. With that, a mission that had lasted nearly 20 years came to a close. Cassini had launched in 1 century and died in the next, and in between, it transformed Saturn from a distant smudge of light into a place we know intimately, ring by ring and moon by moon. If you enjoyed this journey across the solar system, share it with someone who looks up at the night sky and wonders, and subscribe to the channel for more stories from the cosmos.